All right. Hey everybody. As I said, I'm up at the Granger building, and I've built a little mock-up. We'll see that in a second when we go out into the lab. And I'm going to lay out some rafters. I'll explain everything as I go through it. Okay. But again, we start with our print. Okay. And this is what we've got right here. You can see that I've got my little building, 4 foot by 5 foot. Got my specifications. We've got an 8/12 pitch, 12-inch overhang. 7/16 OSB sheathing, and that's going to matter now that we're doing layout. We haven't talked about that yet. And then we have 12 inches on center. Okay, so a little different than normal, but because it's a mock-up, that's what I designed, just do a little 12 inches on center. Okay, I've walked through all the math over here. We're not going to go through the math, otherwise the video would just be too long. Okay, we've gone through plenty of this math. Okay, so here's my common math right here. Okay, we've got a run of 2 foot. I've got my C of 14.42. From there I do my A and my B. Okay, if we go over here, you can see that I've done my hip math right here. Okay, my run is still 2 foot. My C changes to my 18.76 inches per foot. Again, using our Pythagorean theorem. Solve for A and B. There's my A and my B. And then over here we can see our jack. Okay, I only have to solve for the A because the B is going to be the same, or the tail is going to be the same as the common. Okay, so now we can see, come back over here, and we've made our little chart of all of our different rafters. So I've got my common, my hip, and my jack. All right, so I'm going to erase some of this so that I can draw some pictures as we go through, and then we'll go take a look at the mock-up. And I can explain some things while I'm doing the layout. All right, okay, let's go out here. All right, so everybody can see that I've started this roof line. Again, very simple building here. We've got a 4 foot wide by 5 foot long building. Okay, you can see that I've got 3 commons in place. I've got a hip in place. Okay, and we are going to lay out a common, a hip, and a pair of jacks. So we're going to lay out one jack I've already cut. You can see my rafters right here that I've already cut, laid out and cut. And then after we do that, I'll talk about it. We'll come out here, I'll put each one of those in place and basically build half this roof line. Okay? All right, so back in here we go. All right. So first off, okay, looking at the sketches that we've looked at before. Again, now I have the ability to use the whole board. So I can see it both in plan and elevation at the same time. Okay, first let's look at our common. Okay, and this is what we're going to build. Okay, now I can see it in both plan and elevation. I'm building my common, which is this common right here, any one of those 4. Okay, and again, we can clearly see the information that we need to see, that my run is half of that span. Okay, so that means that that bottom leg of that triangle is going to be 2 foot. Okay, from the center of that ridge to right here is going to be 2 foot. That's my run. Okay, but we solved for our A dimension, okay, and our B dimension. Okay, so I'm going to add a couple of things here that we haven't seen yet, because now we're discussing layout. Okay, I've got my 2x4 wall that we saw out there, and I've got my 7/16 inch sheathing. Okay, my 7/16 OSB sheathing. Okay, so we look at that, and again, we know that our A takes us to the outside of framing. Okay, so we've got to be concerned about that 7/16 sheathing, because you can see that I have to take it into account when I do my layout. Okay, why do I wait for my layout? Could I figure that out right in my math? Yes, I could. But do we always use 7/16 sheathing? No, we don't. There's all kinds of opportunities or options for sheathing. I could have 5/8, 3/4, 1/2 inch. Okay, so we don't worry about that until we do our layout. Okay, but again, we're ultimately talking about the same thing. A carpenter has to have the ability to read the print too and understand these details. Okay, so again, demonstrating the math. So again, we solved our A is at 2 foot 4 and 13/16. And our B is at 1 foot 2 and 7/16. Okay, and again, so understanding that my span is going to, my run, my span is going to take me outside of framing to outside of framing. Okay, if I drew the other side of the rafter here, which means that my A is actually taking me from the center of my ridge line. I have to understand that too. So from the center of my ridge line to outside of framing is the A dimension we solved for. From that point to the tail is the B dimension that we solved for. So I look at another aspect that we haven't talked about yet. Who knows what that's called? Some of you know. It is subfascia. Okay, again, a part of my details. I would get into my details and I would understand that. How thick is that subfascia? Well, if we're using 2x material, it's going to be 1.5 inches thick. So we have to take that into account too when we're laying out our rafters. Again, I could have determined that with my B dimension, but I'm not going to because I have all kinds of options for my subfascia. It's usually 1.5 inches, but it could be something else. Okay, so we do that while we're doing our layout. All right, so again, we're working on our common right now. We're going to lay out our A, we're going to lay out our B dimension. Okay, we'll talk about that while we're laying it out, and then we will go out into the lab and do so. All right. Okay, up on the ladder, bud. All of you can't see him, but my son is videoing this for me. And he's going to go up onto a ladder so that you guys can look down on this while I lay out my rafter. Okay, before we do that, we look at our framing square again. Okay, again, to review what we talked about, the skinny part is the what? It's the rise. The fat part is the what? It's the run. Okay, when we laid out stairs, we put the rise in our right hand and the run in our left hand. When we lay out rafters, we do the opposite. We put the rise in our left hand and we put the run in our right hand. Okay, but the square is still pointing towards me. Okay, and it's still, again, a square. It's 90 degrees. You can see that my rise, I've marked what? 8 inches. That is my rise. Okay, it's my unit rise. And you can see my run, I've marked 12 inches. That is my run. It's my unit run. So 8 and 12 would be my unit run. So again, in the real world, I would put square nuts on there, but for our purposes, we're going to put tape on there so that you can see it. All right? Okay, so step number 1. And I take my 2x4, I hold my 8 and my 12, and I come up to the top left-hand corner of my rafter, my future rafter, and I make my first mark. Okay? When we think about that, what part of the square did I use? I used the rise of the square. Why? Because I'm laying out this cut right here. Is that a rise cut? Yes, it is. Okay, again, it's a rise cut. We call it a plumb cut. Okay, but we've already talked about that. Are those two words interchangeable? Yes, they are. Rise equals plumb. Okay, run equals level. Okay, so we'll see that as we move through. All right, so now I've laid out my first rise cut, but again, my actual cut is going to be what? Okay, I have to compensate for the thickness of that stock. Okay, in our case, it's a 2x. Okay, so what's half the thickness of a 2x? Okay, we know the thickness of a 2x is what? 1.5 inches. So half of that would be 3/4 inch. So on my rafter, I compensate for that 3/4 or that 1.5 inches, half of that by marking 3/4 inch. So I mark 3/4 inch on my framing square, okay? And I hold my rise and my run again, 8 and 12. Okay, I could hold it on the top of the rafter if I wanted to. Okay, I'm holding it on the bottom of the rafter. I just have to make sure that I hold it on the same side of the rafter. I cannot do this or this. I have to be on the bottom or I have to be on the top. Okay? All right, so I hold my 8 and my 12. I slide until I hit that mark. And I make my final rise cut for my comet. All right, now from there, we know that our A dimension takes us from that first rise cut that we made, because that's the center of my ridge, to the outside of my framing. Okay, that's why I made this first rise cut. Okay, that's why I showed it to you. That's the center of my ridge right there. This is my actual cut line. Okay, because I compensated for that 3/4. Again, why did I do it in the framing? Why did I do it in the layout? Because does that ridge have to be 1.5 inches? No, it could be anything. It could be 4 inches. It could be a steel beam. It could be anything. Okay, so I compensate for whatever that is when I'm doing my layout. Okay, so I hook the center of my ridge and I mark the math that we determined, 2'4" and 13/16. Okay, so 2'4" and 13/16. Okay, now where am I? I'm coming to this point of my bird's mouth, right here. Okay, again, is that a rise cut, like that one? Is it parallel to the cut above, right there? Or is it a run cut? It's a rise cut, okay? I'm laying out this vertical cut or plumb cut. So what part of the square am I going to use? I'm going to use the skinny part of the square because that's my rise. Okay, so 8, 12, I hold it the same place, and I make my first rise cut. Okay? All right, now I want to lay out my run cut. I want to lay out a level cut right there. Okay, that's this part of my bird's mouth right there. Okay, well, how do I know how to lay that out? Okay, right there. How do I know how to lay that out? Okay, do I know that thickness of my lumber? Yes, I do. It's a 2x4, so that means it's 3.5 inches thick. Okay, again, understanding my print, understanding all of my material. Okay, reasoning this out because I understand my print and my material, my details. Okay, I can determine how to lay that out by saying, all right, if my 2x is 3.5 inches and I'm starting at 12, I would count 3.5 inches. 1, 2, 3, half. So 15.5 inches. What if it were a 2x6? Well, I would do 5.5 inches from 12. What if it were a 2x8? I would do 7.25 inches from 12. Okay, but it's not. It's a 2x4, so it's 3.5 inches. 12, 13, 14, 15.5. Starting at 12, 1, 2, 3.5. Okay, so I slide until I hit that 15.5. Okay, all right, that's right there. All right, now I need to compensate for my sheathing. Okay, again, I can see that that's taking me to the outside of my framing. And again, I have all kinds of different sheathing thicknesses. I could have 1/2 inch plywood. I could have 3/4 plywood. Okay, I could have 5/8. I could have 1.25 inch. Okay, I could have Den's glass, Den's gold, plywood, OSB. Okay, all the different possibilities that I could have. In our case, we have 7/16. Okay, so I compensate for that 7/16 by marking 7/16, drawing another rise cut perpendicular to the rise cut that I just made by holding 8 and 12. No matter where I go on this board, if I hold 8 and 12, okay, I know that my rise cuts are going to be perpendicular to one another and my run cuts are going to be perpendicular to one another. I come back to my run cut, I extend it all the way to my new cut line. Okay, right there, and that would be my cut. Okay, one little caveat, most codes say that I have to have a minimum of 2 inches. Okay, so I check for that. Very rare that I'm actually going to lay out a raptor on a 2x4. I'm usually going to lay it on something much bigger, 2x6, 2x8, and I would always have 2 inches if that's the case. But since we've got a 2x4, we'll go ahead and talk about it. So I mark 2 inches because the fat part of my square is 2 inches. I hold 8 and 12 again. I come to that point and I mark my final cut line. Okay, right there. So that would be my cut line and that would be my cut line. Up here, that would be my cut line. Okay? All right, so now we lay out the top of our raptor, the bird's mouth, and so now we have to lay out our tail. Okay, so again, my tail is 1 foot, is that right? 1'2" and 7/16. I didn't write the 2, I guess. Okay, so 1'2" and 7/16. Okay, from what point? From the framing, from the first rise cut that I made. Okay, that's why I did it the way I did it. Okay, to the outside of my subfascia. Okay, so I see that I've got 1.5 inches. I've got to come back up that 1.5 inches. Okay, and I've got to start from the first rise cut. Okay, everybody should be able to see that with our drawing and understanding what we have here on our raptor. Okay, so I'm going to measure my 1'2" and 7/16 from my first rise cut because that's where my math takes me from. Who set up the math problem? I did, okay? So I'm going to lay it out accordingly, okay? Now, again, I said from that point I know what? I've got to come back up 1.5 inches. Okay, so looking at our square, we know that the rise is 1.5 inches thick. The skinny part of the square is 1.5 inches thick. So all I have to do is hold my 8 and my 12 and come to the correct side of that mark. And I can mark both sides of that square, and I'm coming back up 1.5 inches. And so now that is my cut line. Okay, so everybody should see that. Okay, so now again, I would cut it right there. I would cut it from here to here. I would cut it from there to there. I'd finish it with a jigsaw. Or I'd finish it with a Sawzall, and then I would cut it right there. Okay, and then from there, I would have my common laid out to fit that building that we're building. All right, so let's go on out into the lab, and we will put our common in place. Okay, everybody can see that I've built my common here. I've got my plumb cut. Okay, that was my cut at the top. I've got my seat cut. That was the cut at the run cut of my bird's mouth. I've got my heel cut. That's the plumb cut of my bird's mouth. And then I've got my tail. Again, I was 1.5 inches longer, but I came back up 1.5 inches so that I could eventually put on a sub-fascia right here. Okay, everybody should see that. Okay, but this is my common, so we're going to put that in place. Should be good to go. All right, so now we're going to lay out our hip. Okay, everybody should see that my hip is always one size bigger. Okay, so if I had 2x6s for rafters, which would most likely be the case, I would have 2x8s for hips. Because my bird's mouth is significantly deeper, significantly longer, and we'll see why when we get to our layout. Okay, I'm going to lay it out on a 2x4 just for practice sake, but you can see that when I actually built it, I used a 2x6. Okay, all right, so back in the lab we go. So now for our hip. Okay. All right, so now my hip, my A is 3 foot 1.5, and my B is 1 foot 6 3/4. Significantly longer than my common. Okay? All right, so a few things to understand here. Hips are fairly complicated. Why? Because we're seeing a triangle in elevation. Okay, we saw a triangle in elevation with our common. Okay, but with our common, we saw a square in plan. With our hip, we're seeing a triangle in elevation and another triangle in plan. Okay, so a little bit more complicated. I'm having to understand a triangle both in plan and in elevation. In plan, it's a 45-degree triangle, 45, 45, 90. In elevation, it's an 8-12 pitch triangle. Okay, but we know that with a hip, because I'm hitting that top plate at 45 degrees, my triangle becomes an 8 over 16.97. Okay, because that's the hypotenuse of my 45-degree triangle. Okay, so again, that's what we did with our math, is we understood it as a triangle in plan, knowing that that's a 45-45 triangle, and then we understand it as an 8-12, or more specifically, still an 8-12. This riff will always be an 8-12 pitch, no matter what I do, no matter where I measure it. Okay, but the rafter itself is a triangle in elevation at an 8, 16.97. Rise over run, definition of slope. Okay? All right, so that means what? That means that when I look at my framing square, okay, my unit run remains 8, but my unit rise remains 8, but my unit run becomes what? 16.97, or 17 for the sake of rough framing. Close enough, okay? So I have to move my tape to 17 for a rafter that hits the top plate at 45 degrees. Okay, why? Because in elevation, I understand it as an 8 over 16.97 triangle, or for the sake of layout, an 8 over 17 triangle. Okay, all right, so back up the ladder, bud. All right, oh, there's my pencil. In my ear. Okay. All right, so every rafter starts the same way. I come to the top left-hand corner of my rafter and I draw my first rise cut. Only now I'm holding 8 and 17 on my framing square. Okay, so I come up to 8 and 17. Top left-hand corner, and I draw my first rise cut. Okay? All right, so looking at that, we think to ourselves, all right, well, the next step I took with the common is I shortened it 3/4 of an inch. I compensated for half the thickness of that ridge stock. Correct? That is what we did with our common. But is that the case with my hip? Okay? No, it's not. Okay, if I were to expand that, and we'll pretend that we have a common right here, because with our layout we don't, but it makes it a little bit easier to understand it with a common. Okay, so if I were to expand that, I would have this ridge. This is the easiest way to look at it. Common, common, and common. Okay, again, regardless of whether there's a common on that ridge or not, this is still the same aspect. My hip would just come in only halfway. Okay, so right there is my hip. Okay, so what's that mean? That means that I shortened this rafter 3/4 of an inch. I shortened this rafter 3/4 of an inch. I shortened this rafter 3/4 of an inch. So what do we see? We create another box. Okay, maybe I just put that a little more in the middle. We create another box. Okay, and each one of those boxes are what? 3/4 by 3/4. And we can see that again, another 45-degree angle. We shorten the hip, the hypotenuse of a 3/4 by 3/4 box. Okay, and we can see that by expanding what's happening at the top of our rafter. Well, okay, then how much do I shorten my hip? Okay, if I have a box, and that box is 3/4 by 3/4, okay, can I solve for the hypotenuse? Yes, we can, the way we've done it a million times. Convert that to decimals, and I say c squared equals a squared plus b squared. So c squared equals 0.75 squared plus 0.75 squared. Okay, if you work it all the way out, what you'll realize is that, by converting it back into inches, okay, that I would shorten that 1 1/16 inches. So 3/4, my hypotenuse is 1 1/16 inches. I encourage you to go ahead and work that math all the way through, but you will see that my answer comes to 1 1/16 inches. Okay, so very similar to our math, the question I ask myself is, what does my rafter do at the top of my rafter? If my rafter comes into the top of my rafter at 90 degrees, I shorten it 3/4 of an inch. If it comes into the top of my rafter at 45, 90, I shorten it 1 1/16 inches. Okay? So, again, a tad more complicated, but we can understand it using our math. So instead of 3/4 of an inch, this time I'm going to mark it 1 1/16 inches, go back to my 8 and my 17, and I'm going to remark my rise cut. Okay, this time shortening 1 1/16 inches because I understand that it's the hypotenuse of a 3/4 by 3/4 triangle. All right, going back to our little drawing, expanding what we see right there. Okay, again, what we just drew out, expanding at that top there. I've got my ridge. I've got my commons. again, if we pretended that we had a common in right there, okay, I'll show this to you a little bit differently in a second. What do we see? We see that my hip does what at the top? It comes to a point. Okay, it's not a straight cut. Okay, what would that cut be if I were perfectly level? It would be 45 degrees. I've created another 45-degree triangle. But am I perfectly level? No, I'm not. I'm at some angle. Okay, and again, that's been defined for me. I'm at an 8/12 pitch. Okay, 8/1697 for my rafter, but 8/12 for my roof line. Okay, so what do I have to do in order to compensate for that 45-degree triangle? Because knowing that I'm not level, that I'm at some elevation, okay, I'm not level, I'm at some elevation, what do I have to do? Okay, well, in order to do that, we go back to our framing square. Okay, tell me if you can read that. We go back to our framing square. And what does my framing square say? If I look at the very bottom row, it says side cut, hip or valley use. Okay, what does that mean? It means that a side cut is an adjusted 45-degree angle for whatever pitch I'm building. Okay, so we know what row to read under. What number do you think we would read under? Probably our 8 because it's an 8/12 pitch. Correct. So my 8/12 pitch, I'm going to drop all the way down and I'm going to see that it reads what? 10 7/8. Okay, does everybody see that? I drop underneath my 8. My last row reads 10 7/8. What is that saying? That's saying that if I held 12 and 12 on any 2 points, I would create a 45-degree triangle. Correct? A 45-degree angle. Okay, so what it's telling me is that if I hold 12 and 10 7/8 on those same 2 points, I'm now adjusting a 45-degree angle for an 8/12 pitch. Okay, a little confusing, but that's all I'm doing. 12/12 would be a 45-degree angle. 12, 10 7/8 would be a 45-degree angle adjusted for an 8/12 pitch. Pretty cool, right? Okay, framing squares are very cool. All right, so in order to do that, I have to expose the top of my rafter. I have to square across that last mark that I just made. So I square across that mark, and then I have to find my center point. So if my 2x is 1.5 inches thick, I measure in how much? 3/4 of an inch. So I find my center point, okay? So now I go back to my framing square, and again, if I were to hold 12 and 12 on any 2 points and come across that center point, I would make a 45-degree angle cut. Okay, but I don't want a 45-degree angle cut. I want a cut adjusted for my pitch. Okay, so instead of holding 12 and 12, I hold 12 and 10 7/8. Okay, and then I make my side cut. Again, what is my side cut? It's an adjusted 45-degree angle for an 8/12 pitch. Okay, if I were coming to a point, I would flip my square over, and I would do the same thing again. 12 and 10 7/8, and I would make my mark. Okay, so we'll go ahead and do that because that's what we're showing as our example. That's not actually what I laid out in the lab, but you get the point. Okay, so there I have my side cut. So now I'm finally going to go back to my pitch, 8 and 17, and I'm going to come to that side cut mark that I just made, and I'm going to draw my final rise cut. Okay, so all these rise cuts perpendicular to one another, I would measure that angle. Okay, it's a little less than 45 degrees. I would set my skill saw at that less than 45-degree angle, and I would make this double miter cut. I'd cut up that rise cut, hitting that angle. Okay, all right, so pretty cool stuff. It's all my math. All right, so now I'm done at the top. Okay, so now I have to measure out my A. 3 foot 1.5 inches, and again that takes me from my ridge. So I hook my tape, I mark off 3 foot 1.5 inches. Okay, I put my 8 and my 17, and I make a rise cut. Okay, now what? Now what do? Do I hold 3.5 inches? Do I add 3.5 inches to my 17? No, I don't. This is proof that no matter where I measure on this building, okay, it's going to be an 8/12 pitch. My common is my main rafter. Okay, it's my rafter that's at an 8/12 pitch. So are my jacks. Anything that hits my top plate at 90 degree is my main rafter. Again, this hip is coming in at a 45-degree angle, but it's still setting the stage for the rest of my main rafters, anything that hits at 90. Okay, understanding it in plan as a square, understanding it in elevation as a triangle. Okay, so I have to refer back to my common rafter, and I have to find what is called my X-common. Okay, so let's sketch out our common rafter real quick. Okay, so we've got our ridge. Okay, again, remember, this is my hip right here. This is my hip. This is my common. Okay, so we've got our common rafter. Okay, we already laid it out. We already put it in place. Okay, I've got all this. I already talked about all that. Okay, I've got my A and my B. Okay, my X-com, okay, is right there. It's that amount that I take out of my bird's mouth, okay, to build my common rafter. So in order to lay out my run cut for my hip, I have to determine my X-com. Okay, it's my X, my unknown, from my common. Okay, and again, it's that dimension from there to there. Okay, what is that? Okay, well, let's go back to our common and find out. Okay, come on down, bud. Okay, oops, I told you the bottom dimension, sorry. Okay, so come on in here, buddy. My tape, it's right there. It's from there to the top of my rafter. It's 2 3/4. I told you backwards in the lab. Okay, so it's from the seat cut to the top of my rafter. Okay, plumb straight up. So if everybody can see that, I'm measuring 2 3/4 of an inch. Okay, so okay, back to our math. Sorry, I told it to you a little bit backwards. It's from here to here. Okay, and again, it's different every time. In our case, it's 2 3/4 inch. Why is it different every time? Because my pitch is different every time. Depending on the pitch is going to determine where that sits on top of my top plate. Okay, in our case, 2 3/4 inch. All right, so we go back to our, going back up the ladder, bud. We go back to our rafter. And I measure the same distance, 2 3/4 inch, okay, from top to bottom, because I measured from top to bottom before, 2 3/4 inch. Oops, I didn't write that right, did I? 2 3/4 inch, sorry. Okay, all right. So now I can lay out my run cut. Hey, did I do that right? Yes, I did. Okay, all right. So now that would be my cut mark, and that would be my cut mark. Okay, again, I'm on a much bigger rafter. Everybody understand that? A much bigger piece of material. I'm just showing you on a 2x4. Okay, so I'd be much, much deeper. Okay, but I'm still not done. Okay, one thing that I have to do is called dropping my hip, because right now I've laid this out to the edge of my rafter, and I need to lay it out to the inside of my rafter, to the center of my rafter. Okay, so if I want to lay it out to the center of my rafter, I say, all right, how thick is my rafter? In my case, it's 3/4 inch thick. Okay, so I measure up that cut that I just made, 3/4 inch. Okay. It's getting very carpenter on you, but that's okay. I measure up 3/4 inch right there, and then I measure from the bottom of my rafter to that mark. I'm reading 3/8 inch right now. Okay, I don't know if you can see that or not. And then I make my rafter sit deeper on my bottom plate, on my top plate I mean, by marking that 3/8 inch up. Okay, and then that means that that's going to be my new cut line, and my rafter will sit a little bit lower on my top plate, which is what I want, because I want my sheathing to hit in the center of my rafter, not the edge. Okay, oops, so I mark that. Okay, that would be my cut line, and that would be my cut line. All right, just hold. I'm gonna go grab a different pencil. All right, so I'm back. Sorry, I broke the lead on my pencil. Okay, so again, I hold my 8 and my 17, and I draw my final run cut. So that would be my cut line, and that would be my cut line. All right, so now we're done at our bird's mouth. Okay, now we got to lay out our tail. Okay, be 1 foot 6 3/4 inches. Okay, so I measure out my 1 foot 6 3/4 inches. Okay, I draw my first rise cut. Okay, again holding my 8 and my 17. Okay, and you'll see this when we get out into the lab. What do we see? Or actually, let's go out in the lab and look at it. Come on, bud. What do we see about our hip? Okay, you can see right here that just like at the top, my hip comes to a point, just like we talked about at the top. Here I don't have a common end, so this hip isn't actually coming to a point, but I still have one side cut. It's just going to come to the center of that rafter. But down here, same thing that I talked about having at the top is that point. I'm coming to a point. Okay, so I have to do the same thing at the bottom that I did at the top. I've got to use my what? What was it called on my framing square? My side cut. Okay, I've got to use my adjusted 45-degree angle for my pitch, my 8/12 pitch. Okay? But what else do I have to do? On a ladder. What else do I have to do? I have to compensate for what down here? For my subfascia. Okay? But I have to do that on the top of my rafter. Okay, so where's my rise cut? Right here. Okay, so again, I square in. Square across, measure in 3/4 inch. Okay, and again, I read my framing square. I already read it once. Okay, I'm going to hold 12 and 10 and 7/8. Okay, for my side cut. But this time, I'm going to hold the skinny part down. Okay, I'm still going to hold the 12 up to my left, just like I did at the chop. And I'm still going to hold my 10 and 7/8 down, just like I did at the top, to my right. Okay, but I'm going to bring the skinny part of my square down here so that I can mark that and come back up 1.5 inches for my subfascia, like I did at the bottom, or at the top. And I flip my square, same thing again. 12 is on my left, 10 and 7/8 is on my right, just like at the top. I slide until I hit that center point. Okay, again, just an adjusted 45-degree angle for my 8/12 pitch. That's all it is. Okay, simple math. Okay, and I'm marking back up 1.5 inches because the thickness of this framing square is 1.5 inches. And that's why it's 1.5 inches. Okay, it was developed that way for this very reason. Okay, then I come back down to my face of my hip. I hold my 8 and 17 again. I come to the correct mark so that I'll make it come to a point. I mark my final rise cut, and then I mark the other side, same thing. Okay, so that when I set that saw at a little less than 45 degrees, I cut up that cut, make a double miter cut. I'll flip my board over and do the same thing. Okay, so again, that would be my final cut line. I'd make my double miter cut at the top, double miter cut at the bottom, 90-degree cut in the middle, knowing that at my bird's mouth, knowing that I drop my rafter to bring it to the center of my rafter. Okay? All right, so hopefully everybody gets that. So come on out in the lab. We will put our hip in place. All right, so everybody can see my hip right here. Okay, again, a little bit different because I don't have a common coming in the middle. My layout just takes me 16 inches on center, so I'm just going to have a set of jacks. Okay, I just did that because it's ease of building it for me. Okay, but I still have a side cut here. Okay, so at the top, I've got my double miter cut. Okay, at my bird's mouth, found my XCOM. I've got a much deeper, okay, much longer bird's mouth because I'm coming into my top plate at 45 degrees, and I can see that that meat right there is a lot more than my 3.5 inches right here. But again, by doing my layout correctly, it compensates for that. And then finally, I come into the bottom of my rafter with my coming into a point, and again, my double side cut, again, an adjusted 45-degree angle for my 8/12 pitch, okay? All right, so we put this guy in place, and then we can do our jacks. Okay, so again, he just comes into the center for me. Okay, all right. So now the only thing we have left to do, and again, I would put 2 hips down the other side. I'm not gonna do that, okay? But I would just, if I were to build this, I would cut 2 more hips for each side over there. I'd put those in place. So now we can put our jacks in place. Okay, and what do I know about my jacks? Okay, a couple of things. One, they're gonna be the exact same, right? Okay, but we should start to be able to see it right here. I'm coming into this top of my rafter at what? At 45 degrees. Okay, so I have to think about a couple of things. A jack is a mixture. Okay, when it comes to layout, I'm hitting my top plate at 90, but I'm hitting the top of my rafter at 45. Okay, with a common, I'm hitting the top plate at 90 and the top of my rafter at 90. With a hip, I'm hitting the top plate at 45 and the top of my rafter at 45. With a jack, I'm hitting my top plate at 90 and the top of my rafter at 45. Okay, so I have to mix some of the layout principles together in order to do that. All right. So back to another 2x4. Okay, and again, we're seeing this in elevation. Okay, so now my A for my jack, 1 foot 2 and 7/16. And 1 foot 2 and 7/16. Why is it the same? Because my on-center spacing is 12 inches and my overhang is 12 inches. So it's going to be the exact same dimension in my math. Okay? All right. So let's lay out our jack. All right, up the ladder, bud. Okay, again, every single rafter, top left-hand corner. But before I do that, I can't forget to do what here? Okay, what's my rafter hitting my top plate at? 90 degrees. So what's my unit run? 12 inches. So I got to move my tape back to 12 inches. I got to move my square nut back to 12 inches. Okay, now unit rise 8, unit run 12. Because my jack hits at 90 degrees at the top plate. Okay, so 8 and 12, come to the top left-hand corner of my rafter, make my first rise cut. All right, now I gotta shorten my rafter. I've gotta compensate for the thickness of that ridge. How much do I shorten it? Okay, what am I doing at the top of this rafter? I'm hitting at 45, what did we say? If I hit at 90, I shorten 3/4 of an inch. If I hit at 45, I shorten the hypotenuse of a 3/4 by 3/4 square, okay, which is 1 1/16 inches. I'm hitting at 45, so it's going to be 1 1/16 inches. So, similar to the hip, I shorten my rafter 1 1/16 inches, 8 and 12 again, redraw my rise cut. Okay, but again, similar to my hip, what do I see at the top there? Again, if I expand that out, right there, okay, I've got my hip coming through right here. Okay, I've got a jack coming in right there. Oops, yeah, that's fine. I've got a jack coming in right there. Oops, no, I did that wrong. I've got a jack coming in like that, and I've got a jack coming in like that. Okay, Okay, right here at the top, I'm hitting at 45 degrees. Okay, but again, I see what? Okay, if I were level, that angle would be 45 degrees. But again, I'm not level. I have a defined slope of 8/12. Okay, so how do I know what that adjusted angle is for my 45-degree angle cut? Well, again, I go back to my framing square and I look at the second to the last line, and that one says side cut for jack use. Okay, so again, a side cut is an adjusted 45-degree angle. So and again, I go underneath my 8, and I see that this time it's 10 inches. So again, if I were to hold 12 and 12, that would be a 45-degree angle. If I were to hold 12 and 10, that would be an adjusted 45-degree angle for a jack rafter. Okay? So just like I did with my hip, I expose the top, I square across, I measure in my 3/4 of an inch, I find my center point, okay, and I hold my square at 12 and 10, 12 up, 10 down, okay, but this time what? I only need one angle. I only need one side cut. Okay, what would happen here? I'm going to cut one jack with that side cut, and I'm going to cut the other jack with this side cut. It's the same side cut. I'm holding 12 and 10, but I can see that my jacks come in pairs. One side cut's going to go one way, the other side cut's going to go the other way. Okay, my jacks lay in pairs. Other than that, they're exactly the same. Okay? So now I make my final rise cut at the top of my rafter, 8/12. Okay, that's my cut line. I'd have to measure that angle. It's going to be even less than the side cut on my hip. Okay, so it's going to be 40 plus degrees. Okay, again, I would measure it with my speed square. Okay, and then I would set my saw so that I could make that double miter cut. Okay, right there. And make that cut all the way across the top. Okay, from here, what's going to happen? Now I'm going to lay out my bird's mouth and my tail. Okay, but I look at my common right here. From here, what's going to happen? It's going to be the exact same as my common the rest of the way. My bird's mouth is going to be the same as my common, and my tail is going to be the same as my common. Again, why? Because we're hitting the top plate at 90 degrees. Okay, I can see that square that I've created. All right, so from there, all I have to do is measure out my A, 1 foot 2 7/16. 1 foot 2 7/16. Okay, I draw my first rise cut. Okay, I hold 3.5. Okay, and I can't do it because I don't have enough room, so I'm not going to try and explain it to you too much. So instead of adding 3.5, I'm going to subtract 3.5. So that'll be 12. Okay, because I don't have enough room. This little rafter's too short. Okay, I compensate for my 7/16 sheathing. I draw another rise cut, exact same thing I did at my common. Okay, I extend my run cut all the way to my rise cut. Double check to make sure that I've got 2 inches. Okay, and I draw my final run cut. Okay, exact same bird's mouth as my common. So cut line, cut line. Okay, then I measure out my B, just like I did with my common, 1 foot 2 7/16. And because I'm hitting my top plate at 90 degrees, I just compensate for my 1.5-inch subfascia right here on the face of my rafter by making sure that my square is on the correct side of that line so I can mark both sides of my square coming back up 1.5 inches. Okay? And again, I would cut 2 jacks. They would be exactly the same, except one of them, my side cut would face this way. The other one, my side cut would face that way. Okay, everybody should see that. All right, so back out to the lab. Okay, you can see got my two jacks cut here. Okay, and you can see that they're exactly the same. Okay, my bird's mouth match, my tails match, but what do I see when I get to the top? Okay, my side cuts are opposite one another. Okay, right? And that's because one is going to go right there, okay, and one is going to go right there. Okay, so we go ahead and put those in place. And then, should be done. Half of our roof line anyways, or partial half of our roof line. All right, and I have my safety glasses on, my old man glasses are safety glasses. Okay, all right, so that's it. And again, I would put 2 jacks over here, I would put 2 hips over there, I put 2 jacks on each one of those hips, and my roof line would be complete. And I would sheet all this, and I'd put my sub fascia on like we talked about, and I'd sheet this whole thing, and I would have a roofing system. Okay? All right, so that's it for this class, everybody. I will give you further direction regarding taking the test and stuff via email. I just wanted you guys to get a chance to experience the layout to some degree. Okay, again, not nearly as good as if you guys were actually doing it yourself. You guys would have actually built a whole mock-up like this. You would have set all the rafters up on the structure that we built, and I feel really bad that you don't have the chance to do that, but everybody's paying a pretty heavy price right now for this thing, and we're all kind of in the same boat. So other than that, I'll be talking to you guys via email. This will probably be the last video that you watch. Please email me and tell me that you watched the video, and then I will give you credit for that. Okay, again, just pass, fail, just give you credit for the fact that you watched it. And then other than that, everybody have a good summer, and hopefully you have see a lot of success in your internships, and come back in the fall, and we're back to normal. All right, everybody, have a good time. Thanks. Bye.